As I already mentioned earlier, in an earlier part, we'll cover now the Java SDK. There are other SDKs in BaSyx, but since the Java SDK is one of the SDKs with most features and also is driven by the Fraunhofer IESE, I'll go into detail here in that SDK. But of course, a lot of the features are also possible to implement and use with the other SDKs. In general, just a few words before we dive into the code. In general, for the SDKs and the Java SDK, an arbitrary IDE could be used. The documentation is mainly based on the Eclipse IDE, and there's also a site that helps you with downloading and setting up the Java SDK in your IDE. At Fraunhofer IESE, we also use other SDKs, so it definitely works also with, for example, Microsoft Visual Studio Code or JetBrains IntelliJ IDEA. And for the other SDKs, C#, for example, you would use mainly the Microsoft Visual Studio. The Java SDK itself is hosted on GitHub. So you can find it here in the Eclipse BaSyx organization. We're in mainly 3 repositories. So BaSyx Java SDK is like the base of the Java code. Then based on that, we have a project for the BaSyx Java components that I showed in the earlier chapter. And based on both of them, we have the BaSyx Java examples, where I also showed one of the examples and will show other examples, where you can really look at examples and how some things are done with the BaSyx Java SDK. Within the repository, you have all the code, and in GitHub, there are also some automatic workflows for building the artifacts, and all the artifacts that you need to really work with the Java SDK or the components or examples are then also automatically built and uploaded to Maven Central. So since the projects here are Maven projects, the workflow is basically automated in a way that the build artifacts are created automatically and then uploaded at the Maven repository, where you can also just download the artifacts without the need of downloading the repository for yourself and building everything for yourself. So I'll also show how that how you can use the SDK in your project without any additional step there. So that's the project structure I just explained. And then if you want to use one of these projects in your own Maven project, you can import the dependency using the pom.xml, which is the descriptor for a Java project with Maven. And there you add this Java SDK or component, whatever you need, with a dependency declaration like that. So in your project, you just add, for example, these lines to if you want to use the off-the-shelf component programmatically for the registry or the asset administration shell server, And if you don't need the off-the-shelf components and want to work with the SDK, you would need to add the SDK. So this looks like that. You have one dependency for the SDK itself. So that's basically the only thing that you need if you just want to add the SDK. And optionally, you could also include the test classes of the SDK by using this dependency specification. So all in all, the features that are implemented in the JDK are always tested with some tests that make sure the code quality and operations in the SDK still work if we change something. So this is also these are also the tests that are automatically executed when before building the artifacts and before all the artifacts are uploaded to the Maven Central. And if you want to use the test classes, you could add that, but most of the time you would basically also only add the dependency to the BaSyx SDK, like so. So for our example here, I prepared a little hands-on. So first of all, I'll show you how to use the off-the-shelf components and start with the registry. So let's go into the IDE. So here on the left, let's see if I can make it a little bit bigger. Yeah, at least the code. Here on the left, you can see the projects. So here on hands-on, I have a project that wants to use the SDK to build an own application. And in the pom.xml, like I just described, I have the description for my project. So here I use the Java SDK in version 1.2.0 and then define this for all my projects underneath. So for the first example that I will show, I have here a little sub-project where the BaSyx SDK and or at least the off-the-shelf component for the registry is included as a dependency. So basically, this one is the only thing that you would need if you would like to work with the registry in this case. And since the registry is also built on the Java SDK, the SDK will also be included automatically as a transitive dependency. So how does it look like in code here? The example I'll show does basically three things. It will use and start the registry. It will, I'll show in a later step. It will start an asset administration shell server by its own and also build an AAS server based on the SDK, not the off-the-shelf component. And then I'll show how you can write a client that uses the SDK to access data from the asset administration shell that is registered at the registry. So first things first. That's basically the main overview over the example here. So starting the registry, starting the asset administration shell, and then start my little application. These two lines here are basically the only thing that you need in order to start a registry using the registry off-the-shelf component. So you create a registry component with the context. So basically this context just says that you can access it at port 8082 And then you started by typing registry start component. So if I run that, it will do also the other things, but I'll first take a look at the registry. Oh, I already started or blocked this port with a component I started before, an example I started before. So I will end that and then run it again. So now the port is free and the example runs without a problem. If you run over that problem that you have another application that already blocks that port, you could just end this application or change your port here. Both solutions would work in this case. So let's see. I have the port 8082, and then I can ask what is registered here at registry. Since this example here already registered some asset administration shells, I already get a response here. So now we have basically the default configuration for the registry. But in the earlier chapter, I showed you that you can configure this off-the-shelf component. So I'll show you also how to do that programmatically. So first of all, let's start with eventing. How to enable eventing with the off-the-shelf component here. Basically in the BaSyx components, you have some configuration classes for all the features. So for example, BaSyx MQTT configuration, MQTT config. And then here you have some parameters that define all the configs that you could also specify in your property files or via environment variables. I'll just enter the endpoint here that I also used before in that example, but now as parameters for that configuration. So now I have the MQTT config, like the property files, and in the registry I enable MQTT with that config, and basically that's it. So if I run that now, let's just reconnect here. I should see the same thing as with the Docker environment. So the MQTT events are enabled for the off-the-shelf component. Now the asset administration shell in the example starts and registers its asset administration shell. And here you already see, okay, the registry fires its events when a new AES is registered. And as before, I could now also register new asset administration shells, and then for each registration, a new event would be fired. All right, let's show a second example. So let's say I want to add persistency. This is done with the BaSyx MongoDB configuration, for example. Mongo config. And here, let's use the most simple one. I need an endpoint to my MongoDB. So there I already started a MongoDB in the background. And let's have a look. And yep, I'll take it from the other config. So that's the endpoint to my MongoDB. Like so. and then I'll have to add the, let's try again. Here, now I get the suggestions also. Connection URL, then second parameter is the database. This will be admin. And then in MongoDB, the data is persisted in a way that you have for each registry entry, or in general for the registry, you have in the MongoDB one collection that contains all the descriptors that are persisted for the registry. So the registry, the name for the registry collection is basically the name of that collection within the MongoDB, where you can find then all the descriptors. So I can basically choose any name here, quick start registry, for example. That's our collection. And then I also have to start the registry with that configuration. So I add that backend to the constructor of that registry component, and yeah, that's basically it. For MongoDB, there is of course also a software where you can inspect what is in your MongoDB, and just to show that, this is the MongoDB Compass where I can do exactly that and see what is stored in my MongoDB. And here on the left side, I have all my collections that are already in there. Now, when I start this, of course, there should be a new collection, quick start registry collection. And within that collection, the descriptor that is added here should be also added to that collection. Run that. And look at my MongoDB instance. It's registered. Just refresh it. I have the quick start registry collection, and in there you can find the one descriptor that has been registered at the registry. And now to make it a little bit more interesting, I can now also register manually, in this case, some other descriptor for imaginary asset administration shell. Add it also to that registry, refresh it, and now I have also the second entry here. Let's see if I can. Bigger. No, but here I have the second entry, my quick start AAS, that is registered at the registry collection. And if I now restart that example, the registry will look at the MongoDB during startup and load all the entries in here during startup. So the second entry will also be in the registry without explicitly adding it afterwards. So it's persisted in the database and then loaded from the registry. So if I use Postman to get all the registered AAS after restarting that, I have two entries. The first one, quick start guide dashboard AS, so the one that is registered after in each one, and then my manually registered AS, the quick start AS. So that's the one I registered earlier, and yeah, basically I can let me have a look here. Yeah, I can delete it, and then in the if I ask the registry, it's deleted also in the registry. So the registry will also always have its data backed up by the MongoDB here. All right. So then we have the first part of this hands-on here. So basically using off-the-shelf components and configuring them programmatically. And now let's get into the next parts. So next part would be creating asset administration shells dynamically. So a quick recap about the structure of asset administration shells before we do that in code. Basically, the core elements of the asset administration shell, according to the meta model, are these three elements. The asset, which represents the physical asset. The asset administration shell header, that basically has some ID for that asset administration shell and also provides main access to all the data within the submodels. And then, of course, the individual submodels that actually contain the data and operations within the asset administration shell. And in the, of course, the meta model also contains some other elements that are defined in the details of the asset administration shell. But as you can see here, the highlighted parts, these are also the core elements, the asset administration shell header, the asset and the submodel. And within the submodel, you can have data and operations. So basically, within the submodel, you can have generically, you can have submodel elements. Basically any kind of submodel element, and most of the time, or the most common element is of the property, so like a single value. So for example, the temperature value from a sensor that, or a single temperature value from a sensor, that would be a single property that shows one number, like the temperature. But it's also possible that you have other submodel elements. So there's not only the property, but there are also other kinds of submodel elements. And just to show some data elements that are quite common in the asset administration shell and can be used there. So apart from the property, you could also have, for example, multi-language property. So basically defining a string for multiple languages, a range between min and a max value, then a reference element that you could use to have a reference to any other element or any other object that is referable. And you can also embed files in your submodel. So for example, data sheets like PDF documents, or other kind of files that you would need to include in your submodel as data. And a part of these data elements, there are also other elements like operations, events, and so on. The only thing I'll go into detail here or cover here is also the submodel element collection that you can use also to structure your submodel. So you cannot only use like one or all the submodel elements in one layer, but you can organize them with the submodel element collection and then structure your data and operations in your submodel. So basically a submodel element collection contains other submodel elements, which also could be submodel element collections, like in this example here. So in this example, we have a submodel or imaginary submodel history, where some borrowings for a driller are included, and then a submodel element collection is used to contain all the possible or all the past borrowings for that driller. So you could use the submodel element collection like a list that contains multiple elements of the same type, like borrowing 1, 2, 3, and so on. But you could also use submodel element collections also to structure your submodel as shown here. So like one borrowing contains some properties like position x, y, diameter, and depth of that borrowing, and yeah, contains other properties. In the future, with a newer version of the meta model, this will be also made explicit, so that there will be a list and a collection, or a list and a structure. But with version 2 of the meta model that is also implemented in the Java SDK, you would use submodel element collections for both kinds, so listing elements and structuring them like so. So that's the theory. Now let's look at the code of how to do that and how to use the elements and create a submodel via code. So in the same example here, we also started an asset administration shell with some data within. And this asset administration shell here is included in the other project here, like dummy AAS, that just contains an asset administration shell with a submodel and an asset. So here you also have the 3 core elements of an asset administration shell, like the asset. As you can see, let's also make it a little bit bigger. As you can see, the dashboard asset, so my newly defined asset, extends from asset. So that's a part of the meta model that is provided by the SDK. So here in the asset, I just define, in this case, some minimal values like identification or its name and the kind. Then for asset administration shell, the next thing, it also extends from an implementation in the SDK. And here, this is basically the header of that asset administration shell. So I also give it here an ID. And for the sake of this example, that's it. And the interesting part is in the submodel, because there the data and operations are contained. So in the case of our example submodel, we create a dashboard submodel. And let's have a look here what is done in this example. Basically, also for a submodel, we give it a name. It's set ID short. So ID short is basically a locally unique name for that submodel. And we say that's the dashboard submodel. Then we set the identification and a semantic ID. So the semantic ID of an element in the asset administration shell meta model basically defines what that element means, or what the meaning of that element is. Because in the asset administration shell, it's also quite a feature that you can not only specify or put like data into the submodels or into the asset administration shell, but also annotate the data with its semantics. So, for example, if you have a now for the temperature property, if you have a concept that defines outside temperature in Kelvin, then you, as you can also see here, you can not only add that or set that temperature property, but within that temperature property can also set the semantic of that temperature property, so that an application that also knows this concept can look for properties that represent like an outside temperature, and then know exactly, okay, the value within that property is not just like 5, but if this 5 is also annotated with the semantics of that property, then the application can know, okay, this is not Celsius, this is Kelvin, and this is not just any kind of temperature, but it's an outside temperature. And that's the meaning behind this semantic ID. So now we have a semantic attached to that submodel and also that property here. And within that submodel, we add one temperature property. So it's a property, also an implementation in the SDK. And for the property, we also give it a name, temperature, and set its value. And in the SDK, you could set the value like so. You could just say you could just say, okay, my temperature property has a value of, I don't know, 3, and this 3 is the type float, for example. But then so basically you can also set like static values. But what you can also do with the Java SDK is that you create lambda properties, which means that whenever that property is triggered or queried, a function is called that computes the new value of that property. So basically with this code or this 2 or 3 lines, you say the temperature property is set to a lambda property, and whenever someone asks for that temperature value, then basically here a random property between min and max is returned. So whenever an application asks for the temperature here in this example, then a value is returned between 20 and 30. So now we have the asset administration shell header, the asset and the submodel. And now we'd like to upload that to some AES server. And we could just upload it to an off-the-shelf component. I'll also show how to use off-the-shelf components later. But in the Java SDK, you can also create servlets by your own and basically use that to distribute your deployment. And I don't know, for example, you could have your device operational data hosted at the device, and then have other submodels hosted somewhere else. And with the SDK, you can really program your servlets and servers quite easy. So basically here in this example, it's in this few lines of code, a new server is added that hosts that asset administration shell that is provided there. So we create the asset administration shell, asset and submodel, and add the asset and the submodel to the AES, and then we create a servlet with some context that contains the AES and the submodel. So this is the creating the asset administration shell dynamically, and then creating the server or a servlet. that is started, and then in the next step, the asset administration shell is also registered at the registry. So basically for this, we use the registry context that is defined earlier in the executable there to get the endpoint of the registry. And then we also create a descriptor of that asset administration shell, add a descriptor of that submodel that is contained there, and then just register it at the registry. And this register AS basically waits until the registry is up, and then uses an AS registry proxy to just basically, that's the most important line here, to just call registry.register and the previously created descriptor. So this behind this line, you can find code in the SDK that handles all the HTTP REST call and the JSON serialization and deserialization that is necessary for using the HTTP REST API for registering the descriptor at the registry. Yeah, so that's all for that part. So we created an asset administration shell dynamically, started a server, and register it at the registry. So let's take a look how that works when we run it. Okay. So we run it, and let's use Postman again to manually query the server. So the context here is port 81. This should be that one. No. Because I don't use the AS off-the-shelf component. Can just the endpoint is a little bit different. Let's yeah, okay. I changed the port, but basically you use or query it like before. So it uses the AS API, but at your own server. So localhost 8081, and then AS server AS, and then here looking for example, our dashboard submodel, and then as a response we get all the structure that we defined before. So our dashboard submodel with the ID and all the submodel elements with this one property, so basically the temperature. I can also ask it a little bit more precise, so 8081, and ask explicitly for my temperature submodel element, and then I'll get as a response the one property. So temperature is the property, and the value after this query is 29 roundabout. And every time I ask the server for the temperature property, I get a new value with the lambda property. So every time I click send, the value changes randomly. So in this way, I can even add some dynamic code into properties values, or with the Java SDK even at other parts. But basically, if you wanted to create some lambda properties, you could use the Java SDK in this regard. Now let's look at the third part of the example, and this would be the client part. So up until now, I always used Postman to really manually trigger the endpoints and really look at the property. But of course, when I use the Java SDK, I would also like to do that programmatically, so that I can write an application that uses asset administration shells and really queries the data from there. And for that, in the Java SDK, there's one main class or main facade for accessing your environment, and that class is the Connected Asset Administration Shell Manager. And the Connected Asset Administration Shell Manager basically handles all the REST calls for you. So you can use it to ask for a specific asset administration shell, and then the manager asks the registry for the descriptors of that AES and looks for the endpoint in that descriptor, and then returns to you the asset administration shell representation that you can easily use to query that AES. And that is a connected asset administration shell. Basically, in the Java SDK, there are connected variants for also other parts of the meta model. And these connected variants are implementations that handle all the REST calls for you. So these, they use the API, serialize and deserialize the JSON payload, and basically do the heavy lifting for you, so that you can just use them to like get values of properties. So in the Java SDK, for all the meta model elements, there are local implementations like the property we saw before, or the submodel that really represents the data locally, and also implementations as connected elements, so connected property, connected submodel, connected asset administration shell, that you can use to query a remote element. So let's look how this is done in code. So that's basically the last part of that example here. We have the hands-on run AES client. And here, the only thing that we really need is the endpoint of the registry, because that's basically the entry point for our AES environment. And the application, that's basically the only input for our client here. So the client gets the registry context to get this registry endpoint, and then it creates an AES registry proxy and a connected asset administration shell manager to be able to access all the elements in our AES environment. So the connected AES manager is then used to get our property value here in this example. So here in we want to get a connected property to be able to get the value of that property. So what do? The connected asset administration shell gets us the asset administration shell, taking only the ID of the AES that we want to query. And then in the next two lines, we use that connected AES to get the submodels, or the submodel that we want to retrieve. And in that submodel, we get the property that we want to get, so the temperature property, so that all in all, we get our connected property. And with that connected property, it's really easy to just query the value from that property. So we can just say connected property getValue to create our REST call and get the value of that property returned. And all that this client does is basically periodically getting the value of that property and then printing it out to the console window. So if we run that executable again, we see the output is produced by our AS client application. And every 2 seconds, the property is queried and the value is printed to the console window, like so here. So every 2 seconds, a REST call is created, and in the AS server, because this property is a lambda property that returns random values between 20 and 30, as we already discussed, every 2 seconds we get here a new value. The remaining output here is because of this, the MongoDB has nothing to do with the AS client. All right, so that's our first example. So in this example, we covered quite a bit. So basically, if we wrap it up, we looked at how to use off-the-shelf components programmatically and also configure them in a really easy way. So here still we have the MongoDB configuration, for example. You can just go put it back to default configuration, and then it's really easy to use these off-the-shelf components, also with configuration. Then we use the Java SDK to dynamically create an asset administration shell, including a submodel with dynamic content. So this lambda property where the value is generated every time it's queried. And we used the SDK to create a client application that accesses the property using the HTTP REST API. So what's coming next? What we didn't cover yet is our asset administration shell server off-the-shelf component, and also how to really use the ASX files together with the off-the-shelf component. So we did that in the components chapter before, that we just created an ASX file and then uploaded it to a server. But in the chapter before, we had one constraint or one restriction, and because of the off-the-shelf component is like configurable in some way, but not in any way you want, and the ASX file just contains static information. We didn't have any behavior in the example before. And we can change that with using code. So basically, what we will now do is loading an ASX file, pushing the content of the ASX file to our off-the-shelf component, to the server, and then also adding behavior to it. And we do that by making use of operations. So now we really look at how to run dynamic code with the operation submodel element, and thereby also adding behavior to the uploaded asset administration shell. Basically, we do this in adding behavior. We do add behavior in 2 ways. First of all, with the control submodel, I'll show you how to use operations that run code. And second, we have our current temperature here. I already showed you how to use the lambda properties. So basically with these lambda properties, you can connect your property with some data source also. So instead of just generating the random values, of course, you could also add code that queries some database, for example, to get the value. This would basically be delegating the call to your real data source. But you could also connect this current temperature with a data source by periodically or event-based updating the current temperature. So for example, each second you could update the current temperature to the actually current temperature. So the difference would be delegate is the current temperature is updated each time it's queried, and update would be independent of the queries to the submodel data. The property is updated at some time, either periodically or event-based. And for operations, we will add code to it also programmatically. So let's have a look at it. I think it's easier if we just jump into the code directly. So our hands-on 2 also is quite simple. We also have our registry. That's basically the same as before. We just started the off-the-shelf component. The most interesting part is the asset administration shell here. So here we want to load an ASX file into the simple OpenAS server. And then application, that's basically nothing new. I will skip over that. So let's look at how this works. So first of all, in our project here, we have the simple OpenAS, and in there we have our ASX file. So the ASX file, if I take that, the ASX file just contains the static structure of our asset administration shell, the submodel and its submodel elements without any behavior. Now, what we would like to do, if I jump into the simple OpenAS component, is loading that ASX file and then adding behavior to it. So that one basically loads the bundle from the ASX, loads static bundle, and then we connect the open bundle with some behavior. So how do we import the ASX file with from code? Therefore, in the Java SDK, there is the ASX to meta model converter, and you can use that to import ASX files, and then just use the converter with the path to the ASX file. So here, OpenASX, and then it will automatically pass all the data within that file and just return in a bundle all the meta model elements that are basically described here in this ASX file. Likewise to that meta model converter in the JDK, you can also in the SDK, you can also find classes for deserializing like JSON and XML files. Yeah, but here we have the ASX file, so we use that ASX to meta model converter. So that's that line. And now we have in the bundle all the static information or the static structure of our ASX file. And now we'd like to connect it. So for our sensor submodel, we want to update our temperature value. So what we do here is basically just taking or creating a new thread, and each 200 milliseconds we use our property from that we got from that bundle to update the value. So basically in update current temperature, we see that if we didn't set a manually set temperature, then we generate also a random value. And with current temp prop set value, we just update the value here. So all in all, a new thread that runs as long as this program runs and updates the value every 200 milliseconds. In a real scenario or real use case, of course, instead of generating random values, you would write code that fills that value in a meaningful way. So, for example, have code that queries your sensor to get the data and then update the property. And what about this manually set temperature? So that's what we use in the operation. In the control submodel, we have one operation, and in this code, we add code to that operation and link the operation interface with some actual code. So here we also get this the operation from our control submodel that's in the bundle, and then basically here we have the operation and set the invocable to that consumer. So the operation basically can get a parameter, and then all this operation here does is setting this manually set temperature to the target temperature that we got from the parameter. And the effect of that is that when we called that operation, our current temperature here will always be returning that manually set temperature in the future instead of generating random values. Of course, in a real use case, you could add or link any code to that operation. So you could basically call services in operation, run algorithms, and so on. But in the simple example, we just say, okay, we take the parameter and set our temperature here. The code below also shows an alternative, but I won't go into detail here. So there are basically two ways to set these invocables for the operation, but let's just leave it here. Basically that's already it. So to wrap it up and then try it out, we have a registry as before, or we can use an application also as before that uses the REST API to access that asset administration shell then. The only thing that we had here is in the AS server component, we loaded the structure of an ASX file in code, and then from the static ASX file structure, we added behavior. So for operations, we added runtime behavior, and for the for a property, we added or we update the property regularly in a new thread. So this would also be an alternative to connecting your property with any kind of data source by code, by using the Java SDK. And if we run that and then look at how the server behaves in Postman again, So we let's have a look here. Now it's now it's the AS server has the port 4001. So no, it's the other one here. Yeah. So basically here I'll just get the sensor value like so from the AS server, the endpoint, and now default behavior is every time that I get the value from that cone temperature property, a new random value is generated. Yeah. And now I can also invoke that operation to set my own manually set temperature. So basically, the content of the payload and the endpoints, you can all find it in the Swagger documentation. But basically, I use an HTTP post to invoke the operation and pass it some arguments. So here I set one input argument, the target temperature, which has the value 1.25. So now I run the operation, and if I now get the sensor value, it will always return this 1.25. So all in all, the previously static AS from the ASX file is modified in a way that the AS server also has some dynamic behavior.